Hello guys, I'm Nathan, and today I'm gonna do the AP Calculus BC 2022 FRQ question 6. And part A, using the ratio test, find the interval of convergence of the power series for f. Justify your answers. So remember that the ratio test is pretty easy. We can just write it x 2n plus 1 plus 1 over 2n plus 1 plus 1 times 2n plus 1 over x 2n plus 1. Notice that I did not write the negative 1 to the power of n in because it really doesn't matter, because the answer we get is gonna be a absolute value. So remember, we also need to write the limit as n approach to infinity of the whole thing right here. And we can cancel a little bit, so it's gonna be 2n plus 3 over 2n plus 3 times 2n plus 1 x 2n plus 1. And what we got here, because n is approaching to infinity, we can just cancel these out, because as n is infinitely big, the difference between here, it doesn't matter. And we can just cancel x, and the difference between these two coefficients is 2, so we can left out the x squared equals to absolute value of x squared, and is less than 1. This is what the ratio test do, and so we can imply that negative 1 is less than x less than 1. Pretty simple here, right? So next step, we need to remember to test our endpoints. So endpoints. So let's try negative 1 out first. So f of negative 1 is equals to negative 1 plus 1 over 3 minus 1 over 5 plus 1 over 7, which, since it is alternating and decreasing, so by the alternating series test, it converges. So let's try f of 1. It's equals to 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus dot dot dot. And again, because of the alternating series test, it converges. So conclusion is, because both endpoint converges, and we can put our endpoints in, is the interval of convergence. Okay. Part B, show that f of 1 over 2 minus 1 over 2 is less than 1 over 10. When we saw this part, we have an absolute value with a weird negative 1 over 2. And if we remember the definition of the alternating series test, the error of the estimate. So basically what this function is doing is they're using the first term to estimate the error, to estimate f of 1 over 2. And the error will be the next term after 1 over 2. So basically what they do here is they plug in f of 1 over 2 and then uses the first term to estimate, and f of 1 over 2, the absolute value of f of 1 over 2 minus 1 over 2 is equals to the error, which equals to the next term of the series, which is x cubed over 3. And for x, because what we tell to estimate is negative is 1 over 2. So we do 1 over 2 to the power of 3, which equals to 1 over 24, which is less than 1 over 10. And this is given by the answer. So question. So this can clearly state that 1 over 10 is less than, 1 over 24 is less than 1 over 10. So this is definitely less than the error. Part C. Write the first 4 non-zero terms and the general term for an infinite series that represent f prime of x. Oh, that seems pretty similar. F prime of x. We can actually write f of x first. This equals. Actually no. I'll just write f prime of x, and the derivative of x is just 1. The derivative of x to the power 3 over 3 is just x to the power of 2, and we actually kind of notice a pattern here. So it's just gonna be plus x4 minus x6, and this is the first 4 terms, and the general term is gonna be, because it's alternating, so we need to put a negative 1 to the power of n. It's just simply x to the 2n. F part D. Find the value of f prime of 1 over 6. So if what we notice here, it is actually a geometric series with the ratio of 1 over 6 to the power of 2. So we just use the formula a1 over 1 minus r. a1 equals 1. R equals 1. Because it's alternating, so we need to also add a negative sign. Negative 1 over 36. So first term 1. First term is just going to be 1 over 1 plus 1 over 36. Easy, right? So equals, this is 1 over 37 over 36, which equals to 36 over 37. And this for part D. Thanks for the patience, and here it is. Thank you.